Here we have an alternating series, and I want to show that it converges by the alternating series test, and then I will also show that it converges to 12e to the negative 1 minus 5. Let a sub n be the expression n squared plus 4 over n plus 2 factorial. So a sub n plus 1 is this, and which simplifies to n squared plus 2n plus 5 over n plus 3 factorial. And so now let's show that the limit of a sub n is n approaches infinity is equal to 0. So we have the limit of the expression n squared plus 4 over n plus 2 factorial, and then the bottom here we can write it as n squared n plus 2 times n plus 1 times n factorial. And then the product of n plus 2 and n plus 1 is n squared plus 3n plus 2. So we can see that this part right here, as n approaches infinity, this part will approach 1, and then this right here will approach 0, and so we get 0. And then the next part, we need to show that the a sub n plus 1 is less than or equal to a sub n for all n starting at 1. And so here is a sub n plus 1, and I'm going to rewrite the numerator as n squared plus 5n plus 6, and then minus 5n minus 6, and plus 2n plus 5. And then the n squared plus 5n plus 6, the factors are n plus 3, n plus 2, and then the rest of it is just minus 3n minus 1. And then we can rewrite this as n plus 3 times n plus 2 over n plus 3 factorial, and then minus 3n plus 1 over n plus 3 factorial. N plus 3 factorial is the same as n plus 3 times n plus 2 factorial, and the factors n plus 3 will cancel each other out, and then what's left is just the n plus 2 over n plus 2 factorial. And then over here we just get the 3n plus 1 over n plus 3 factorial. And since n starts at 1, and so this term right here is positive, and so this whole thing right here will be less than n plus 2 over n plus 2 factorial, since this term is positive. But n plus 2 is less than n squared plus 4. This is a sub n, and therefore we have shown that a sub n plus 1 is less than or equal to a sub n for n starting at 1. So we have just shown that these two conditions right here are met, and therefore the infinite series, this alternating series, converges by the alternating series test. And now let's show that the alternating series is converges to 12e to the negative 1 minus 5. And so here we got the expression n squared plus 4 over n plus 2 factorial, and then I'm going to rewrite it as n squared plus 3n plus 2 minus 3n minus 2 plus 4. The factors here are n plus 2, n plus 1. And then we have the minus 3n, and then minus 2 plus 4, it's just 2. And then the minus 3n plus 2, I will rewrite it as minus 3n plus 2 plus 6 plus 2. And now we'll go ahead and split this up. So this will be n plus 2 times n plus 1 over n plus 2 times n plus 1 times n factorial. And then this part here we get minus 3 times n plus 2 over n plus 2 n plus 1 n factorial. And then the last part here we get 8 over n plus 2 n plus 1 n factorial. And then right here, this will be simplified to 1 over n factorial. And then this right here we get 3 over n plus 1 factorial. And then over here we just get 8 over n plus 2 factorial. And so our infinite series becomes the summation with the expression negative 1 to the n times all of this. And then we can write it as summation, sum of summations, like this. And then now we just need to find the value of each sum right here. Recall that the power series representation for e to the x is 1 plus x squared over 2 factorial, and so on. And then if x is negative 1, then we get 1, negative 1, and then 1 over 2 factorial, minus 1 over 3 factorial, and so on. So 1 minus 1 is 0, so e to the negative 1 is this infinite sum right here. And then from here, if we just subtract 1 from both sides, we get e to the negative 1 minus 1 is equal to the infinite sum starting at negative 1. And then from here, if we move this 1/2 to the left side, then we get e to the negative 1 minus 1/2 is equal to this infinite sum that starts with negative 1 over 3 factorial. And then the last result that we need is multiply this right here. If we multiply both sides by negative 1, then we get negative e to the negative 1, and then equal to the infinite sum that starts with negative 1 over 2 factorial. And so the sum with the expression negative 1 to the n over n factorial, if we write out the terms, then it will be the infinite sum that starts with the negative 1, which is this right here. And so it is equal to e to the negative 1 minus 1. The infinite sum with the infinite series with the expression negative 1 to the n over n plus 1 factorial. And here are the terms. And so this is the infinite sum that starts with negative 1 over 2 factorial, which is this right here. And so it's equal to negative e to the negative 1. And then the last thing we need is the series with the expression negative 1 to the n over n plus 2 factorial. And here are the terms. So this is the infinite sum that starts with negative 1 over 3 factorial, which is this right here. So it's equal to e to the negative 1 minus 1/2. And so this is our original series, and then we rewrote it as the sum of these three summations right here. And I have just shown that this series right here, this infinite sum here, is e to the negative 1 minus 1. And then this summation right here is negative e to the negative 1. And then this summation right here is e to the negative 1 minus 1/2. And simplify everything. We have 12e to the negative 1 minus 5, which is approximately negative 0.585446. And so in summary, this series right here converges by the alternating series test, and then the converges to 12e to the negative 1 minus 5. And that's the end of the video.